and welcome. Thank you for joining us today. My name is Jillian Formentin and I am the Engineering Director for Clough, and it is my absolute pleasure to be talking to you today, mostly because of our very special guest that I'll introduce in a moment. So this is a series of podcasts where we are interviewing our experts, our engineering experts that are doing their engineering brilliance as part of Clough's projects around Australia and actually around the world. Ananda Yapabandara, otherwise known as Andy, is a principal civil structural engineer and has been with Clough for the last 5 years. So it's an absolute pleasure to welcome you today and thank you for accepting the invitation to be part of our podcast series. And it's my actual pleasure to meet in person with you, Andy, because I normally work in Perth. So it's great to meet with you today. Andy's been with Clough for 5 years and joined us as a principal engineer. So he's been a very important part of the growth of our business in Brisbane and in fact across the whole of the East Coast, and it quickly became an integral part of the APAC engineering team. So he's a real thrill to talk to you today, but also because you've recently received an important internal Clough award, which is the Make a Positive Impact Award, which is part of our Pioneering Award program. So really congratulations for winning that award.
Yeah, thank you very much, Jillian.
So maybe we'll start, but maybe you tell us a little bit about yourself. I'm really curious to learn about you, like how's your career brought you to Clough?
Yes, I'll start with where I was born. I was born in Sri Lanka. After school, got a scholarship to go to Russia to study engineering.
Oh,
So
wow.
I studied in Moscow for 6 years in Russian language and graduated from there. After that, I went to UK and did a master's in structural engineering at the Queen Mary College, London. After that, I worked in the UK for a few years before coming to Australia. And when I first arrived here, I worked for the Sydney Water Board. After that, I joined Aker Caverna, which is a Norwegian company with whom I did work for them in London as well before joining Clough.
Okay, great. Wow. Well, thank you. And I'm really thrilled that your career brought you here because you've been doing some amazing things with Clough. And I thought we'd start with talking about, well, what you won the Making a Positive Impact Award for. Now, that was for some pretty interesting work that you were doing with the team on the Snowy Mountain project. So would you just tell me a bit about what actually happened, what were we able to provide, and what were the positive impacts?
When Clough was awarded the Snowy Hydro project, I was very excited. I thought we can really get into some good designs. But unfortunately, it didn't happen in that way. After a few months, Salini was looking for a temporary works design engineer. So I actually nominated somebody who they interviewed and they were in the process of recruiting him. But the approval process took long. So they needed somebody urgently. And I volunteered to go to Cooma and stayed there for a couple of weeks doing their temporary works design. And when I returned to Brisbane, we just carried on. So they basically made me a temporary works design engineer, and my workload got so big, I had to recruit another young engineer, and we worked together for about 2 years. And when I first started, I hadn't done much tunneling myself, but I picked up all those things because engineering is engineering. It doesn't have to be you're a tunneling engineer, you're a bridge engineer. Basic engineering applies to everything. So that's how I got into it. And we managed to sort of sometimes redesign, somehow improve some of the consultants' designs. One was a typical example was this consultant design had a 400 thick slab, which was for the factory which made the segments for the tunnels. So it's a huge factory. It's like 300 meters long, 60 meters wide. It's a large floor, about 3,000 cubic meters. But we managed to reduce it to 2,000. We saved 1,000 cubic meters by redesigning the slab. So that's how we sort of, impressed them, and they kept giving us more work.
Oh, fantastic. Well, thank you for doing that. That sounds like it was really exciting. I think for people that are listening that are interested in learning more about that project, I think there's a lot of information on LinkedIn. I know I've been seeing a lot of updates as to Snowy Mountain Hydro 2.0. I know there's another interesting project that you were sharing with me about before. In fact, some quite complicated civil and structural issues that came up on the power station that you've been working on with the team here. What could you share with me about what are some of the design issues that you dealt with that power station project, and how did you and the team overcome those issues that came up?
Yes, this power station had a 360-ton generator, which was a 300 megawatt generator. So the power station was an extension to an existing power station. So the 360-ton turbine had to be supported on pedestals and foundation. What happens with turbines is that they are rotating equipment. So the manufacturer of the generator, they were very specific on the limitations of vibration in terms of amplitude of vibration as well as velocity of vibration. So we got an expert engineer from Brisbane to design it, but he did design, but the manufacturer would not. We met all their criteria, but they was insisting on doing it on like a finite element analysis. Fortunately, we had Strand 7, and I had used it previously, and my young engineer, Sean Huang, he also learned it very quickly. And we managed to remodel the whole thing in 3D, sort of carried out that analysis and showed them that everything was in order.
Oh, very good. And what did that, because that would have been some interesting conversations between us and the supplier of the equipment, and also anyone else providing services.
One of the main problems with the vibration of foundations is the actual earth underneath it. So in this particular case, we had the sandstone, and the manufacturer was insistent that we can't put it directly on the sandstone because it becomes too stiff and it might have very high frequencies of vibration. So we cut it down by a meter and filled it back with some road-based material, which is quite strong. But unfortunately, the values given to us by the geotechnical engineer was very low. And we knew they were low, but we couldn't convince them. So we had to go to get a second opinion. Eventually, we and did some more geophysical tests. They were like getting the shear velocities of the rock.
What does it take to get those readings? So what do you actually have to do?
Yeah, well, to get a shear velocity of rock, what they do is they drive like a pole into the ground at 2 points and then send a signal from one pole, and it gets received at the other end. So if the rock is fissured and broken up, it takes much longer to get to the other end. So the higher the velocity of transmission, the higher the rock strength.
So it's like the conductivity of the vibration through the rock.
Through the rock.
Okay, and if it's broken up, it's slower, but if it's all intact, it's going to be
intact, all solid rock. And this is what it proved out to be, luckily. And after that, once we got the right sort of soil parameters, we managed to get that design completed.
Oh, very good. Excellent. And then I understand that the concrete pour was like imminent. That was scheduled for the next day and things needed to be decided quickly.
This concrete foundation was 37 meters long by 10 meters wide by 2 meters thick. They needed to employ 2 batch plants to keep it going quickly. The main problem with the foundations, when they are 2 meters thick, is the due to exothermic reaction, the temperatures of the concrete in the middle can be very high. And what causes cracks in concrete is the differential of the temperature at the surface and temperature inside. So that differential shouldn't be more than 25 degrees centigrade.
Right.
But internally, it can go up to 75. It's very hard to contain that. So the secret of maintaining that difference is to cover the slab and like a blanket with a air pocket all round. Obviously, you got formwork which are insulated, but in the top of the slab is the exposed part. So we put special blankets with air pockets underneath it and maintain that difference to less than 25. So at the surface, it could have been like 55 degrees.
Right, so does that allow it to heat and then cool uniformly so it doesn't cause those cracks coming through from the centre? Okay, great. And you're also, I think at that time too, you're also battling a lot of rain. You mentioned water, I think it was raining a lot, and there was all sorts of different issues that you had.
The other major issue was this plant is right next to a big lake.
Right.
The surface level was only about a meter above the water level in the lake. So when they do excavations, water pours in. So they had to have dewatering systems as well. And the other problem was when you dewater, that means you pump water out. They couldn't just pump it straight into the lake because there could be contaminants.
Right.
So they had to be treated as well.
It's so interesting, and anyone walking past that power station in years to come are going to see a structure above the slab more. They're going to see the shed, they're going to see the power station itself and that amazing equipment.
Yes.
None of it's possible without the slab that's going to hold it there for decades. It's such an example of engineering excellence, and a lot of the work of an engineer is only visible if something goes wrong. Of course, I tell you what, people would know that slab was there if it cracked, wouldn't they?
That's right, yeah.
It's not going to, and it'll be doing its job invisibly for decades. So,
Engineers never get the credit for what they do sometimes because it's all covered up, as you say. Only when they go wrong, they get the blame.
That's right. It's often the plight of the engineer. We're only famous when it didn't work out.
Yeah, when something falls down or something.
And, people that will be listening to our conversation, some people are embarking on their career as an engineer, and some are quite new. And something that's really, I think, valuable for people in their first few years is they're often wondering, what is it should I focus on? Where, if I want to be doing great projects and contributing and making a real positive difference with my career, what would you recommend that our young engineers are focusing on?
Right. First thing I should say about going into a career is that you should always pick something you like. That's the number one thing.
Yeah.
Because otherwise it will be a dreadful thing to
dreadful experience.
Exactly. So once you decide that, you should even look at your prospect of employment or anything else. I mean, to a certain extent you have to, but the most important thing is you pick the subjects you like. Once you get into a workforce, being a young graduate, always try to learn your discipline before embarking on project engineering. So that's very important. Also important, go to site. It's not just formulae and calculations, but to actually go there and experience site as well. And also what you should concentrate is learn all the Australian standards, not the most easy to read documents. Once you know that, then reading Australian standards will sort of make you realize, how you should approach design.
I got some very good coaching from a very senior engineer when I was a young graduate, and the coaching was, don't try and remember what's in the standard,
Exactly.
but build a relationship with the standard so that you know where to find what you need. What he said to me was, if you try and remember what's in the standard, your memory's not necessarily the best way of keeping that, it
can be dangerous.
It can be dangerous, that's what I'm trying to say, exactly. But don't rely on your memory, but build a relationship so you know how to interact with the standard, where to find what you need. Yeah, I have the opportunity, I've actually been on the committee for 5 Australian standards. They were gas standards, so not the standards you use, so they were the gas utilisation standards. And that was a very interesting thing too. I certainly built a very interesting relationship being the contributor to what goes into the standards and how we come to that. So this is also the time of year where we are interviewing prospective graduates, so people that are finishing their university. And a question that I'm often asked is, how important is it to get the best marks that you can? And how do we make sure that we have the right people joining our teams? It's often a conversation we have internally. Yeah. Well, what's your view as someone who's like, dare I say, 30 years down the track from that point? What do you think about that?
My opinion is that very important to have the right attitude, the positive attitude, being keen to learn and all that. But it's just as important, if not more, is to have good people who are competent in their own subject. So if you have done well at the university, it will be a lot easier for you to pick up the design work.
Very, very good. I think that's a very balanced approach, because we do say marks aren't everything, yes. And it's a ticket in.
Yes.
So, if you're joining a company like Clough, and we're very proud of all our graduates, and we're proud of the opportunities that our graduates get to develop and learn from the masters like yourself. And it's an important time, like you said, too, where you're translating that theory into real practice, like really making a positive impact with your learning. And in those first few years, some of the things that you learn at university that are very theoretical suddenly begin to make sense. And in a career like in a company like Clough, got many different expressions of your engineering. Like we have, I think you mentioned a few minutes ago, project engineers and Clough are engineers who have a grounding in the discipline. They are then working perhaps towards being a project manager. Are getting more learning with regards to project controls and how to be financially responsible for a project, but also managing the whole workforce that goes into constructing one of our projects.
People who want to go into project management or become project engineers, for example, first, please learn your discipline first. Yeah. At least spend 5 years learning it, and some design, some site work. Definitely spend some time on site, and then only move on to project, like becoming project engineers.
So when you look back over your career, what would you say you're most proud of in being an engineer in our industry?
I won't use the word proud. I'm sometimes happy about it. Yeah. I don't have too many high peaks to talk about, but I have been very consistently good at doing what I'm doing over the years. And I can honestly say I never dread going to work. Never.
Never? Yeah.
It's funny how, because generally speaking, I usually get on well with people I work with. Obviously, if it wasn't the case, you wouldn't want to go to work. I can understand, even if you like the work. But on sites as well, which I enjoyed. But the most interesting part about structural work is you design everything from scratch. So you are not looking at some sort of a guide book or pick something from a catalog or something like that. Just purely everything from scratch. So that's the part which really appeals to me.
So beautifully said. All right. Well, thank you. Well, thank you for speaking with me today.
Yeah,
but also thank you for being one of our most senior and principal engineers of the business, making sure that our projects stand up forever and do what they're supposed to do. But also important part of your work, which I also really appreciate, is where you're passing the knowledge on to the younger generations. It's such an important part of our engineering discipline, and being able to pass that on and making sure that we're learning and growing as a profession. I really appreciate that.
Thank you.
All right. Yeah. Well, thank you. Well, we've been talking to Ananda Yapabandara. Thank you. It's been lovely to speak with you today. And congratulations on your Making a Positive Impact award that you won recently. And I look forward to talking to you more in the future and seeing what else we can build. Thank you for joining us today. You've been listening to an episode of the Clough Expert Series podcast. So thank you for joining us today from wherever you are listening from. And I look forward to bringing other experts to you in months to come. Thank you.